In this video, I'm going to be going through how we can simplify radical expressions. Now, these are just expressions that have square roots or cube roots or any sort of root in them. So I'm going to be using some of the rules that we have for simplifying radicals. So let's go into some examples. Let's say that I have the cube root of 27 squared. So this is actually the same as me writing the cube root of 27 raised to the second power. And this is due to one of the properties of radicals, that if you have some number to some root and that number is raised to a power, this is the same as writing the root of that number raised to the power. So in this example, we have the cube root of 27 raised to the second power. Well, the cube root of 27 is just the number 9. So we have the 9 raised to the second power, and that gives us 81. Let's say that we have the square root of 49 raised to the third power. So I'm going to use that same rule to rewrite this expression as the following. So this is the same as me writing the square root of 49 raised to the third power. The square root of 49 is just the number 7. So we have 7 raised to the third power, and that number comes out to 243. Let's do some more examples. So let's say I have the cube root of 64 over 125. So there's another rule for radicals, that if you have a fraction under some sort of root, this is the same as writing the root of both of the numbers as a fraction. So I'm going to use this property to rewrite this expression in the following way. So this is the same as me writing the cube root of 64 divided by the cube root of 125. And this works in the same fashion that the exponents are distributed to top and bottom if you were to raise this to a power. It works the same way because when you take the cube root, you're essentially just raising the entire thing to the 1/3 power. So the cube root of 64 is just 4, and the cube root of 125 gives me 5. So this fraction is fully simplified, and this is my answer. Let's say that I had the square root of 81 divided by 100. So again, I can rewrite this in the following way. This is the same as me writing the square root of 81 divided by the square root of 100. The square root of 81 is just 9, and the square root of 100 is just 10. So this is my answer. Let's say that I had the cube root of 216 raised to the third power. So since I have a cube root and I'm raising this to the third power, the cube root and the third power cancel each other out, and I'm just left with 216. And this works because this is essentially me saying 216 raised to the 1/3 power, and I raise that to the third power. And remember the rule for exponents, that if I have some number raised to a power and I raise it to another power, then it's that number raised to the product of the two powers. So in this case, I have 216 raised to the 1/3 times the third power, which just gives me 216 to the first power, which of course is just 216. So let's say I had the fourth root of 32 raised to the fourth power. So again, I can rewrite this in the following way. I can rewrite this as the fourth root of 32 raised to the fourth power. And using the property that I just explained in the last example, you can see that the power and the root cancel each other. And you're just left with 32. Let's say that I had the cube root of 2x cubed divided by 27. So again, I can rewrite this fraction as a fraction of the roots of the top and bottom. So this is the same as me writing the cube root of 2x cubed divided by the cube root of 27. I can rewrite the numerator as the cube root of 2 times x cubed over the cube root of 27. And then I can rewrite the numerator again as the cube root of 2 times the cube root of x cubed. And the cube root of 27 is just 3. And I can simplify the numerator once again, because the cube root of x cubed is just x. So I can rewrite this as the cube root of 2 times x divided by 3. And that's as simple as I can make it. So this is my answer. Let's say that I had the expression the square root of 50 minus the square root of 18. Now there is a property that if I were to divide these two roots together, then I can combine the two values inside each radical into a single radical, but I can't do that whenever I'm adding and subtracting. So what I need to do is I need to break up the inside of these roots into factors that are perfect squares. So I can rewrite 50 as the product of 2 and 25 inside the root. And I can rewrite 18 as the product of 2 and 9 inside the root. And using this following property, that if I have the root of two numbers, this is equal to the product of the roots of the two numbers. I can rewrite the expression in this way. So this is the same as me writing the square root of 2 times the square root of 25 minus the square root of 2 times the square root of 9. Well, the square root of 25 is just the number 5, and the square root of 9 is just the number 3. So what I end up with is 5 times the square root of 2 minus 3 times the square root of 2. And this just gives me 2 times the square root of 2. So another example of this, let's say that I have 2 times the square root of 32 plus 3 times the square root of 72. So again, 32 and 72 are not perfect squares, but they do have factors that are perfect squares. So we are able to simplify these radicals. So this is the same as me writing 2 times the square root of 16 times 2 plus 3 times the square root of 36 times 2. And I can rewrite those radicals in this way. So I have 2 times the square root of 16 times the square root of 2 plus 3 times the square root of 36 times the square root of 2. Well, the square root of 16 is just the number 4, and the square root of 36 is just the number 6, because they're both perfect squares. So I have 2 times 4 times the square root of 2 plus 3 times 6 times the square root of 2. And if I multiply these out, I end up with 8 times the square root of 2 plus 18 times the square root of 2. And since I have a common factor of square root of 2, I can combine these together to get 26 times the square root of 2. And that's my final answer. Last example. So let's say I had the square root of 18 times x to the 5th minus the square root of 8x cubed. So what I can do is I could rewrite the inside of these radicals into something that factors as a perfect square so that we can rewrite those rationals and simplify them a bit. So what I can do is I can rewrite the first radical in this way. I could say this is the product of 9x to the 4th times 2x. And I can rewrite the second radical in this way. This is the product of 4x squared times 2x. And then now that I've rewritten the radicals as products, I can separate them. So this is the same as me writing the square root of 9x to the 4th times the square root of 2x minus the square root of 4x squared times the square root of 2x. The square root of 9x to the 4th power is going to simplify down to just 3x squared. And the square root of 4x squared is just 2x. So I end up with 3x squared times the square root of 2x minus 4x times the square root of 2x. So as far as common factors go, I have a common factor of an x times the square root of 2x in each term, so I can factor it out. So I have x times the square root of 2x, and when I factor it out of both of these terms, I end up with a 3x minus 4. And now this is fully factored. So I hope this video was helpful about learning some of the rules that we have to simplify radicals. And knowing these rules very well is going to help out a lot in all of your math classes to perform even more complicated operations and using radicals in some applications that you would use. So I hope this video was helpful, and thanks for watching, and stay tuned for the next video.